Welcome back. Let's begin with our today's new topic, that is analysis of coal. Now, analysis of coal. See, analysis of coal is very important because it can determine the various constituent present in the coal sample, because that constituent is directly affecting to the calorific value of the coal sample. That's why the analysis of coal is very essential, right? Now, what is the selection criteria for the coal, right? A good quality of coal, it should have high calorific value. A good quality of coal, it should contain low moisture, it should contain low volatile matter, it should contain low ash content, it should have whatever the percentage of the phosphorus and sulfur, as well as uh, the size of the coal sample, as well as the cooking quality of the coal, right? So these are the selection criteria for the coal, right? Now, in analysis of coal, there are two different types of analysis. Number one is proximate analysis of coal, right? Number one is proximate analysis. In proximate analysis, we can determine percentage of moisture, percentage of volatile matter, percentage of ash, and percentage of fixed carbon. In proximate analysis we can determine. Now, in second type is ultimate analysis. In ultimate analysis, we can determine the elemental constituent, means percentage of carbon, percentage of hydrogen, percentage of sulfur, percentage of nitrogen, and percentage of oxygen. It can be determined in what? Ultimate analysis. Now, today we will discuss the proximate analysis of coal. You know that this proximate analysis, it can determine the various constituent present in the coal sample. Which constituent? The first constituent is percentage of moisture, right? Now, how we can determine the percentage of moisture present in the coal sample? A known quantity of coal sample is heated in oven at 110 degrees Celsius, right? For the period of what? 1 hour, right? Then loss in weight divided by weight of coal into 100, we can get the percentage of the moisture. So formula to calculate the percentage of moisture, percent M, which is equal to M minus M1 divided by M into 100, right? So this is the formula to determine percentage of moisture present in the coal sample. So this M is what? It is the initial weight of the coal sample. M1 is what? Weight of coal sample after heating, and this M is what? That is also the weight of coal sample into 100. In this way we can determine the percentage of moisture. Now, in percentage of moisture, what is the temperature condition? 110 degrees Celsius for the period of what? 1 hour. I will again repeat. A known quantity of coal sample is heated in oven at 110 degrees Celsius for the period of 1 hour. Then loss in weight is determined, and this is the formula to determine the percentage of moisture present in the coal sample. Now, the second one is percentage of volatile matter which is present in the coal sample. Number two is percentage of volatile matter present in the coal sample. A known quantity of moisture free coal sample is heated in muffle furnace at the temperature of 925 to 950 degrees Celsius temperature, and for the period of what? 7 minutes. Then loss in weight is determined, right? So this is the way to calculate the percentage of volatile matter present in the coal sample. A known quantity of moisture free coal sample is heated in muffle furnace at 925 to 950 degrees Celsius temperature for the period of what? 7 minutes, and then loss in weight is measured. So formula is what? Formula is M1 minus M2 divided by M into 100, right? So this is the formula to find out the percentage of volatile matter present in the coal sample. If the fresh sample is taken, then we have to subtract the moisture from what? Volatile matter, right? So this is the second concept, that is percentage of volatile matter. Now the third one is percentage of ash. Percentage of ash. You know that ash is non-combustible inorganic matter, is called as what? Ash. So a known quantity of coal sample is burned in muffle furnace at the temperature of 750 degrees Celsius temperature for the period of what? 30 minutes, right? Then weight of residue divided by weight of coal into 100, we can get the percentage of ash. So formula is percent ash, which is equal to what? M3 divided by M into 100, right? So this is the way to calculate the percentage of ash. So what is the M3? M3 is called as what? The weight of residue left or weight of ash divided by weight of coal into 100. We can get the percentage of what? Ash. And last parameter which is determined in the proximate analysis, that is percentage of fixed carbon, right, which is denoted by FC. It can be determined by subtracting the sum of percentage of moisture, percentage of volatile matter plus percentage of ash from 100. We can determine the percentage of what? Fixed carbon. Now, what is the significance of proximate analysis? The significance of proximate analysis is a good quality of coal, it should have low moisture content. It should contain what? Low moisture content. A good quality of coal, it should also contain low volatile matter, low ash content, but it should have higher percentage of fixed carbon, because the percentage of carbon increases, calorific value goes on increasing. So this is the significance of what? Your proximate analysis. So I think we will stop here. So this is the proximate analysis, and these are the different ways to determine the percentage of moisture, volatile matter, ash, and percentage of fixed carbon. Okay, thank you very much.